Okay, so a blank is a transformation that enlarges or reduces a figure. This is a dilation. Okay, a dilation is a transformation that enlarges or reduces a figure. Now we'll talk a lot more about this later in the year, but in this unit where we're talking about similarity, it just goes with it. So we're going to talk a little bit about it here. Now, one thing that's used in a dilation is, well, in a dilation you start off with one figure, then you have another one, and it gets either bigger, gets smaller. That's what this talks about, enlarge or reduce. And so you have two figures, and that's what we've been dealing with. And one thing you use to do that dilation is a scale factor. So it's a number you multiply by that either makes it bigger or makes it smaller. Okay? So we've been using scale factor, just haven't really said that phrase, but we've been using that over and over again. Okay, so in general, the way we find scale factor is it's the new length over the old length. Okay, it's the new over the old. So like if I've got a triangle like this, and then we've got a similar triangle. Okay, I'll get this in just a second. Okay. So let's say on this one, this side is 2 centimeters, and on the one that corresponds, it's 6 centimeters. So the scale factor is the number we use to multiply to get that number right there, from the first one to the second one. So what would the scale factor be here? 3, yeah. 2 times 3 is 6. So in this dilation, the scale factor is 3. And again, we've been using this over and over again. I just haven't used that phrase yet, but that's the scale factor. Now, in this one, it's easy to see. I mean, you can see 2 times 3 is 6. But what if this right here was 4.7 and this was 1.3 or something like that? 1.3 times what gives you 4.7? That's not as easy to see, okay? And so that's why you use this, because that's all you're doing is... Okay, how long is the new one? If we start off here and we go to this, how long is the new length? So 2 is the old one. It's where we started, and it multiplied by 3 to get 6 is the new one. So which one's the new one? Is 6. Over, how long is the old one that corresponds to that? Is 2. And if you do 6 divided by 2, what does that give you? It gives you 3, right? I mean, that's the same thing as this right here. All right. If a scale factor is greater than 1, it produces an enlargement. Wow. Okay. My brain went blank for a second. Enlargement. If the scale factor is greater than 1, it produces an enlargement. That means it's going to get bigger, right? Now, if the scale factor is less than 1, and I guess technically I should have said if it's between -1 and +1, but we're not going to deal with any negative scale factors really, so this will work. But if a scale factor is less than 1, it produces a reduction. Okay? Scale factor is less than 1, it's going to make it smaller. Okay, so what I want you to do is to plot those 3 points right there. Okay? Number 1, go ahead and plot these 3 points, and then use that ruler that you grabbed to make sure you draw straight lines. So plot those 3 points and connect them. Okay, so -2, -3, 3, -3, and 4, 2. So it should make a triangle like this. Now, what we're going to do is we're going to dilate this by a scale factor of 3. Okay, scale factor of 3. So as you think about what I set up here, what's going to happen? Is this going to get bigger or is it going to get smaller? Yeah, it's going to get bigger, right? That's what the first line says there. If the scale factor is greater than 1, it's going to produce an enlargement. So after I dilate this using the scale factor of 3, we're going to have a bigger triangle here. All right, so the way we do this is we just multiply every single piece times the scale factor, in this case of 3. Okay? So every single one of these numbers is going to get multiplied times 3. So what is -2 times 3? Is -6. And what is -3 times 3? Is -9. Okay, so that one's going to become this one. Okay, the 3, -3. If you multiply both of those by 3, what are you going to get?
9. Positive 9 and negative 9.
Yep, +9, -9. And then if you multiply this last one here, 4, 2 by 3, what are you going to get? 12, 6. Okay? So we started with this triangle, and it's going to become this triangle now. So go ahead and plot these 3 new points. -6, -9, 9, -9, and 12, 6. And I know the 12, 6 is going to go off the grid here, but just kind of estimate where it should be at. So we have -6, -9, 9, -9, and 1, 2, 3, 4, 5, 6. Go 2 more about right here. Okay, so there's our new one. Now, I just want to look at one thing here real quick. So on the original one, on the one that I drew in red there, this side down here on the bottom, how long is that side of that triangle? Just count how many units that is. How long is that?
5.
It's 5 units, right? Now, how long is the same one that corresponds to that on the new triangle? So if we count here, is what?
11.
So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 units. So it went from 5 to 15. Does that make sense with our scale factor? What was the scale factor we used here?
3.
It's 3. So this one was 5, this one's 15. Does that make sense? Yeah, 5 times 3 of the scale factor gives us 15. Okay, so that looks good. All right, next one. Go ahead and plot these 4 points. We're going to make this quadrilateral here. Number 2, plot those 4 points. -8, 6, -1, 2, 3, 4, 5, -6, -6, 4, -2, and 8, 10. Alrighty. So on this one, we're going to dilate using a scale factor of 1/2. So is this going to get bigger or smaller?
Small.
Smaller. That's what this says up here. If the scale factor is less than 1, it produces a reduction. Okay. So again, everything gets multiplied by 1/2. So what is -8 times 1/2? Is -4. And what is 6 times 1/2? Is what?
3.
Is 3. Yep. So that turns into that. What is the -6? -6 going to turn into? It's going to turn into a -3, -3. What's the 4 -2 going to turn into? 2 -1. And then what's the 8, 10 going to turn into? It's going to turn into 4, 5. Okay, so let's plot those new points for our new quadrilateral. So -4, 3, -3, -3, 2 -1, and 4, 5. Okay, so we started off at the one that I drew in red there to the blue one. Did it get smaller? Yep, sure did. Okay, using that scale factor of 1/2, it's going to reduce the size of it. Okay, now on the back. So on this one, it's got both pictures. It wants us to say what the scale factor is, okay? So that's what we're going to do. And all of these, it's going to be going from A to B. And the order of this definitely matters. So what they're saying is to go from A to B. So you're starting at A, going to B. So on the first one right here, okay, going from A to B. So from A to B, is that an enlargement or a reduction? Reduction. It gets smaller, right? So I know that my scale factor is less than 1. This is going to have to be less than 1 for the scale factor. Now, there could be a lot of ways to do this. The easiest way is going to be find the side that I can count easily. Like this side right here, would it be easy for me to count how long that side is right there? No, because it's on a diagonal. I'd have to think about some other stuff that's going on. Would there be an easier side for me to count? Yeah, the top. Because I can just count that because it's just like horizontal, goes straight along that. So I can count that real easy. Okay?
Yes.
Good. So on A, that side is 6.
Can you do the same thing with B?
Yep. So let's count how long that same side is on B.
That's a half.
So there's a half here, there's a half here. We're going to assume that. And then there's 1 and 1 here. So how long is that?
3.
It's 3.
It's 2. Isn't it?
Okay? So you're definitely thinking, but we're going from A to B. If you do 6 times 2, where does that get you? To 12, not 3. So it's kind of going the opposite way of what you're thinking. So 6 times what gives you 3?
1/2.
Good. So I'm thinking like this. 6 times what gives me 3? And yeah, that's right. It's 1/2. 6 times 1/2 is 3. Okay? The other way to think about that is like what I told you there on the front, which is really the easier way. If you'll just think about what I'm about to show you right here, this is what you need to do. Okay, we're going from A to B. That's what this is talking about. So that means A is the old one. That's where we're starting, and B is the new one. And like I told you on the front, scale factor is what? It is new over old. So in this case, okay, just looking at those two sides, how long is the new side? 3. over how long is the old side? 6. And if you simplify 3 over 6, what does that turn into? 3 over 6 is simplified as what? Is 1/2, right? It's the same thing as this. I mean, it should be. It is. That's where that came from. So if you'll just think about that, the new over the old, it just tells you right just straight away what it is. Okay, on this next one, on B, again, going from A to B. Going from A to B on this one, is it getting bigger or is it getting smaller?
Big.
It's getting bigger, so this is an example of an enlargement. Okay, so on A, this side right here would be good to count. How long is this side on A?
3.
It's 3. And then on that same side on B, it's 4. So again, A is the old, that's where it's starting. It's going to B, so B is the new.
So 4 over 3.
So the scale factor here, yep, is new over old is just 4 over 3. Okay? And again, what would happen is if you did 3, took the old number of 3 times 4/3 the scale factor, that's going to give you that 4. Okay, it's just simple math. It's simple algebra what's happening there. Okay? And on this one, okay, so on A, this is going to be the good side to count right here. It's just straight up and down and count it really easy. How long is that side on A? 4. How long is that same side on B? Is 5. And again, we're going from A to B on all of these. So what's the scale factor?
5 over 4.
Is 5 over 4. Just new over old. Okay. On this one, same thing. How long is this side on B?
2.
2. How long is this side on A?
8. Also 2.
Is 6. And again, I'm going from A to B. So going from A to B, it's, oh, and I forgot, so this is a reduction right here. This one was an enlargement. So new over old, B is the new, A is the old. So what's the scale factor here? 2 over 6, right? And then if we simplify that, it just turns into 1/3. All right, that's going to do it for today.